So this video is just a real quick snapshot of a presentation that I used to give that was about an hour and a half in total. So this is going to be it in a nutshell. When we're talking about reliability, which is one of the first concepts that we're going to address, it's really, really important that we think about the stability and consistency of the results. And so students need to be given access to an understanding of this concept. Often they have approached this in science, or they might possibly be doing it in mathematics investigations. But what we have to get them to do is to engage with this again with their own research. And if you can get them to be examining the replicability of the data, that's going to make life a lot easier. The next concept is validity. And validity is often used as a synonym for reliability, and it's not. It's a completely independent research criteria. Now, when you get into validity, particularly in a scientific sense, it's a lot more complicated than what the average student needs to understand to be able to use the term correctly. One of the things that I encourage my students to do is to actually go further and to start to investigate different types of validity and external and internal validity in particular. But giving them real-world examples of validity is really important, because this one is a little bit more abstract and it is harder for them to apply this, particularly because we often use the word valid to mean appropriate, and that's not necessarily the concept in a research term. So you can use this term in two different ways, really, and I guess, again, it depends on the student's complexity in their evaluation and analysis in their folio. When we're looking at primary interactions, a valid sample would be one that is measuring the appropriate group. So they'd be randomizing the test, they'd be getting the right control measurements happening, and they've applied a scientific method to their research. In the secondary materials, and this is where it tends to come up more, particularly for a lot of students who are trying to say that their source was appropriate, what we've got is actually thinking about causal, did this research actually answer my question? Was it an appropriate source to use for my question? And so they'll often say things like, this was a valid source for me to use because it answered my question. Now, that's not a really in-depth, insightful way to actually approach validity, because what we actually want them to be doing is evaluating the argument. So did the person who produced that BuzzFeed article actually get a valid measurement of the data that they then chose to include? So you could say something like, the process of archival research was valid as it allowed me to obtain a variety of academic positions that could be cross-correlated to establish reliability. In this comparison, it was most pertinently identified that source X correlated with source Y, etc., etc. So thinking more about the aims of the research. A good little graphic that can be quite useful with students is the bullseye. So this took me a little while to get my head around the first time I saw it, because I was still learning myself, but I think it's a good way to understand the concepts between reliability and validity. So in the first bullseye, you'll see that the data is reliably hitting a point. It is testing something in the same way. You're getting the same data over and over and over again. But we all know that the point of a bullseye is to get the bullseye. So this is not a valid response to the intention. We're not actually getting what we intended. So as you'll see there with dot point 1, lots of people can believe the sky is purple, but that doesn't actually make it accurate. We see this in things like doomsday cults. Across the bullseye targets there, you'll see different measures. So low validity means it's not hitting the point, and low reliability means it's doing it in all sorts of different patterns. Not reliable and not valid, same thing, but just even more bizarre. And then when we actually hit the bullseye and we get a reliable measure over and over again, we've got data that's doing what it intended and meeting the appropriate requirements.